So it's time for another video, and this one will explain energy transfers. To understand energy transfers, we'll actually get started with the different types of energy that there are. Some of the most common energies that you will come across or that you might have heard about already would be something like thermal energy, also known as heat. Or you might have come across kinetic energy, the energy of movement. If you've ever been hit by a toddler on their bobby car, then you know about kinetic energy. I won't ask about being hit by a car, but you understand what I'm talking about. There's also something that you might have come across so far already. There's gravitational potential energy. That is the energy that something possesses if it is at a certain height. If you need to lift up a heavy box and put it on a shelf, you know about gravitational potential energy. If you cycle up a hill, you're gaining gravitational potential energy, and that's hard work. So let's have a look at other forms of energy that we are familiar with and that would be worthwhile listing here. If you use a car, then you would, if it's a petrol car or using any other fossil fuels, there would be chemical energy stored in the fuel. Actually, if you do use an electric car in batteries, there's also chemical energy stored. The electrical energy that they can give out is stored as chemical energy. Speaking of which, electrical energy is of course a different one. Very, very versatile. That's why we use it so much for so many different appliances. Then there is something that can be used to actually generate electricity, and we rely on that fairly heavily. That is nuclear energy. That means there are nuclear reactions happening in the nucleus of atoms, in the nuclei of atoms, and that energy can be harnessed, and this energy is nuclear energy. Then there are different types of radiation energy or radiant energy, for example, light energy, and other forms of energy that you will have come across and that you might want to list in this context would be sound energy. As you listen to the sound of this video, there's of course energy reaching your eardrum. There's also elastic energy. If you're a bit bored and you play around with a little elastic band, then there's elastic energy that can be stored in there and that can be used to actually torture other people by flicking the elastic band at them, as you very well know. So these are the different kinds of energy, or some of the essential types of energy. So let's have a look at energy transfers now. I've listed a few examples here to give you a bit of an idea, and we'll look at energy transfers, and we'll also look in this context at useful and wasted energy. So for this first example that we see here, the hairdryer, we have as the type of incoming energy, we would have, let me just change this here, we would have electrical energy, of course, coming in. Electrical energy goes into the hairdryer, and what comes out of the hairdryer, sort of the other way around than this is drawn, is of course air that is blown. So this air has energy of motion called kinetic energy. And then you also want warm air to blow through your hair. So there's also heat or thermal energy created. These are the useful types. The wasted type in this context here would be also heat some of the heat might actually be developed in here, as in the due to the friction in the moving parts in your motor, etc. And this heat will not be used. Only some of the heat will actually be used to warm up the air. Okay, so that is useful energy and some wasted energy. I'll just label this here. So this is useful. And this one here would be wasted. So let's have a look at a light bulb and look at what kind of energy goes into this. Again, this would be electrical energy. And what comes out from the light bulb is, of course, light energy. A type of radiant energy, as I called it before. Now, the reason why the incandescent light bulbs, the ones with a little wire inside, are no longer in use in Europe, or are no longer sold in Europe, I should say, is because they actually transferred only about 10% of the overall energy into light. And that means that there's a lot of heat that is generated and that is wasted here. Let's have a look at another type. So one more example. There's also the motor, and if you have a motor, you take in electrical energy again. And what you give out is, in this case, kinetic energy. Now, you probably know that a motor can actually get quite warm, so there is, again, heat wasted. And you will also hear the motor operating, so there's some sound energy that is wasted. The sound energy is not what you want. You don't want the motor to actually warm up. So these are kinds of types of wasted energy. Let's have a look at energy resources in the context of energy transfers. And for this, I have a table here that I want to fill in with you. And we're going to have a look at the different types of energy resources, and then see what kind of energy they actually use. Let's get started with wind energy. So wind energy uses moving air. That means it relies on the kinetic energy. Kinetic energy, also abbreviated as KE. I'll write that here. Yeah, my handwriting, I know, is not very good on this tablet at all. And the energy that is produced, well, in this case, it's the reverse of a fan, so to speak. It produces electrical energy. Of course, it's going to waste some of the energy as well, and that would be heat energy or sound energy. I'm not going to note that down here, but you could write that down. If you have hydropower, your classical hydropower station would actually have water in some sort of a reservoir, and the water would then run down through a pipe. So if this is your reservoir here, you might have a dam here, and then there is some sort of a pipe, and down here you would have a turbine. Okay, you can't read this at all. Up here is your reservoir. Then you would actually convert gravitational potential energy, I'll abbreviate it for legibility and for brevity, to GPE. Gravitational potential energy, because it has some altitude, and then it loses that gravitational potential energy. It's converted first into kinetic energy and then into electrical energy. So it's actually 3 stages of conversion here. So tidal power etc. I think you get the idea. I'll just pick one more type of energy. Let's use the photovoltaic cells. Photovoltaic cells are the ones that you would traditionally know as solar cells, and these take in the sunlight. So it would be light energy or radiant, type of radiant energy, and this would be converted then into electrical energy. So there we go, and you could do the same with the remaining ones. Nuclear power, I just want to emphasize here, nuclear power actually uses nuclear energy. So the nuclear energy. And that is, of course, converted, well, it's actually converted to heat first, then to kinetic energy in the power plant. You have steam created, and the steam then drives a turbine, so that's kinetic energy, and that then drives a generator, and that is again electrical energy. So there we go. The others you can probably fill yourself now with what you know about energy transfers and the different types of energy.